this video, we'll continue on with our solutions from the examples given in the PowerPoint. And here we go with number 3. And in number 3, we want to evaluate the derivative of the given function at the x value 2 times the square root of 3. I put in an extra parenthesis there that didn't belong. And our function is f of x equals x times the inverse tan of x over 2. So we first have to find the derivative of this function, and there's a lot going on to find the derivative here. First of all, we've got two functions that are being multiplied by one another, x times tan. And so that tells us that we need to use the product rule. And in fact, it's x times the inverse of tan, and the inverse of tan has an argument that is more than just x. So because of that, we need to use the chain rule as well. So let's get going finding this first derivative, which again is fairly complicated. Let's start with the product rule. The product rule tells me I need to take the first function, x, times the derivative of the second function, inverse tan of x over 2. So I'm going to refer to my derivative rules. Derivative of inverse tan is 1 over 1 plus x squared. So I'm going to do times 1 over 1 plus x over 2 squared. And again, because there is another function plugged inside of that inverse tan, I have to multiply by its derivative to do the chain rule. So I need to multiply by 1/2. Alright, now we need to continue our product rule. Alright, so that was the first part of the product rule. We did the first function times the derivative of the second function, and I need to also add to that the second function as is, times the derivative of the first function, which luckily is just 1. Let's clean it up. So to clean it up, I've got x divided by 1 plus x squared over 4 times 1/2 plus the inverse tan of x over 2. Keep on moving with this. First of all, we've got a fraction within a fraction. So here we want to get a common denominator to simplify that fraction. And so the common denominator will be 4, which means I'll have x squared plus 4 over 4. And that whole thing was also underneath an x. So now I'll want to simplify this fraction as well. And so to divide fractions, I multiply by the reciprocal. So I'm going to take x and multiply it by the reciprocal, 4 over x squared plus 4. And that will give me 4x over x squared plus 4. Now don't forget here, I still am multiplying by 1/2. And so I can actually simplify these. I can reduce a 2 out of both of those, numerator and denominator, and that will give me a final derivative of 2x over x squared plus 4 plus the inverse tan of x over 2. Alright, the goal of this problem was to evaluate the function at 2 times the square root of 3. So wherever there's an x, I'm going to plug in 2 root 3. And I'm already running out of paper on this one. I think I'm writing too large. Keep on going here. 2 times 2 root 3 is 4 root 3. On the bottom, if I square this, I'll get 4 times 3, which is 12, plus 4, which is 16. So, again, off to the side here, 2 root 3 times 2 root 3. Squaring that, the 2 times the 2 gives you 4. and the square root of 3 times the square root of 3 gives you the square root of 9, and that is just 3. So 4 times 3 is 12. And then again I added the 4 to get a total of 16. That does reduce, the 4 and the 16 reduce to give me the square root of 3 over 4 in that fraction. Alright, we also have to evaluate the tangent of the square root of 3 since the 2's cancel. So that was one of the reasons that I printed that unit circle. So we want to figure out where, I forgot to record my, my inverse symbol there when I was bringing it down one line. So anyway, I want to find the inverse tan of the square root of 3. And so there's a lot to remember from your trig class. And the first thing you want to remember is how do you evaluate an inverse tan function. And so essentially what we want to do is we want to figure out what angle gives us an answer for tan of the square root of 3. And so remember that tangent is the sine divided by the cosine, or on your unit circle, it's the y-coordinate divided by the x-coordinate. Alright, so on my unit circle, I've got a couple of different options. In terms of tangent, the square root of 2 over 2, when I divide those, that's going to give me a 1. So that's definitely going to be out. That's not going to be the inverse tan of the square root of 3. The 1s and the 0s are out as well. And if you remember from trig, there is a specific range involved with tangent, and it goes from negative pi over 2 down here all the way around to positive pi over 2. So we're looking essentially at the right half of the circle. And we also know that we want to get a positive square root of 3 when we do divide sine by cosine or y by x. And so because it's positive, that narrows it down to either pi over 6 or pi over 3. So think about in which one of these would you divide sine by cosine or y by x, and you'd get a square root of 3. And it's actually going to be this one right here. If I take the square root of 3 over 2 and I divide it by the reciprocal, it gives me the square root of 3. So what that tells me is that 60 degrees, or pi over 3, is what will evaluate this expression. So right here, when I wanted to find the inverse tan of pi over 3, we used our unit circle, which we should have memorized, to figure out that that's pi over 3. So in our answer, we have the square root of 3 over 4 plus pi over 3. We could get a common denominator there and add, but I believe that was the answer that was given in the book. Alright, we've got one more problem to do, the fourth problem, where we want to actually write the equation of a tangent line as well as finding the derivative. And the given information on that one was that we had a function f of x equal to the inverse secant of 2x, and we have a given point 1 comma pi over 3. Now you actually didn't have to find the y-coordinate here, but in a lot of previous sections we have had to do that, where we're given an x value and we have to find the y value given the function. So just know that it would be your job to figure out at some point what f of 1 is, or what the inverse secant is of 2. And so once again, it's that same idea of using the unit circle, where secant, remember, is 1 over cosine. And so on the unit circle, that's 1 over your x-coordinate. So where on the unit circle would you take the reciprocal of the x-coordinate and get an answer of 2? And it turns out that it's actually that exact same angle that we had a second ago, pi over 3. So luckily, they gave that to us, but just a little bit of background information in terms of where that came from. Alright, so let's get going with the problem. So first of all, we want to find the derivative of the secant, inverse secant of 2x. Now this does require a chain rule, and it also requires the rule for the derivative of secant, so I'm going to pull that out. And the derivative of secant is going to be right here, 1 over the absolute value of x times the square root of x squared minus 1. And so I'm going to plug all of that in, except I don't just have an x here, I have a 2x for my argument. So everywhere in the formula that there is an x, we're going to put a 2x, and then the chain rule says we also have to then multiply by the derivative of that inner function, which is going to give us 2. So the derivative here will be 2 over the absolute value of 2x times the square root of, I'm going to clean this up here a little bit, this will give me 4x squared minus 1. Alright, remember that the goal was to write the equation of the tangent line. And so to write the equation of the tangent line, we need the point slope formula. Now the point we already have, we already know our x and our y. We're on our way to finding the slope. We just have to evaluate that derivative at the given x value in order to get that slope. So I'm plugging 1 into my derivative, and so that will give me 2 over the absolute value of 2, which is just 2, times the square root of 4 minus 1, which is 3. And that simplifies. We can reduce the 2 to 1 over the square root of 3. Now the book doesn't actually rationalize, but I know most students from their trig work are used to rationalizing, and so rationalizing that denominator, I get a slope of square root 3 over 3. Alright, so tangent equation. Y minus y1, which is pi over 3, equals m, square root 3 over 3, times x minus x1, which is 1. And if we want to isolate the y and put it in y equals form, I'll distribute here square root of 3 over 3x minus the square root of 3 over 3 plus pi over 3. And I believe that's the answer we saw in the PowerPoint.